Next topic is power tariff and its types. The actual tariff that the customer pay depend on the consumption of the electricity. The consumer bill varies according to the requirements. The industrial consumer pay more tariff because they use more power for long times than the domestic consumers. The electricity depend on the following factor: types of load, time at which load is required, the power factor of the load, the amount of energy used. The total bill of the consumer has three parts, namely fixed charge is denoted by C, semi-fixed charge is denoted by AX, and running charge as BY. So the formula will be Z, that means total charge, is equal to AX plus BY plus C. AX is nothing but semi-fixed charge plus BY is nothing but running charge plus C is said to be fixed charge. Power tariff types: flat demand tariff. So flat demand tariff is calculated by the formula Z is equal to AX. In this type of tariff, the bill of the power consumption depends only on the maximum demand of the load. The generation of the bill is independent of the normal energy consumption. This type of tariff is used on street light, sign lighting, irrigation, etc., where the working hours of the equipment are known. The metering system is not used for calculating such type of tariff. Next method is straight line meter rate. So for this method, the formula will be Z is equal to BY. The generation of the bill depends on the energy consumption of the load. The customer need not pay anymore even though the plant incurred some expenditure to provide readiness to serve the customer. It does not encourage the customer to use electricity. Next power tariff type is block meter rate. Here the total amount is calculated by the formula Z is equal to B1Y1 plus B2Y2 plus B3Y3. In this type of tariff, a particular amount per unit is charged for particular block of each unit. The reduced price per unit are charged for the succeeding block of units. This type of tariff reduces the unit energy charge with increasing consumption. What is the demerit in this tariff method? Means lack of measures of the customer demand. Then next tariff method is two-part tariff. Here the amount is calculated by using the formula Z is equal to AX plus BY. The generation of the bill depends on the maximum demand and the energy consumption of the load. It requires 2 meters to record maximum demand and energy consumption of the consumer. It is used for industrial customers. And the last tariff type is three-part tariff. Here the total amount is calculated by Z is equal to AX plus BY plus C. In this type of tariff, the total charge to be made from the consumer is split into three parts. By adding fixed charge to two-part tariff, it became three-part tariff. This type of tariff is applied to big consumers. For an example, here they have given one problem. A power station supplies the following loads are necessary to the customers. So, time in hours they have calculated for a day. So, for 24 hours it will be started from 0 to 6, 6 to 10, 10 hours to 12 hours, 12 hours to 16 hours, 16 hours to 20 hours, 22 hours, 22 to finally 24 hours. So, corresponding load in megawatt they have given. So, for first 6 hours they have the load usage is 30 megawatt, and for next 6 to 10 hours 70 megawatt, 10 to 12 hours 90 megawatt, 12 to 16 hours load capacity, load usage is 60 megawatt, and then for 16 to 20 hours using 100 megawatt, and for 20 to 22 hours 80 megawatt, and finally for 22 to 24 hours load will be 60 megawatt. Using this given data we have to calculate, we have to draw the load curve and then estimate the load factor of the plant. Then what is the load factor of a standby equipment of 30 megawatt capacity if it takes up all load above 70 megawatt? Then finally what is its use factor? So we have to calculate the use factor. So first of all we have to draw the load curve. So in x-axis we have to mention the time in hours, and in y-axis load in megawatt. Then just like an graph we have to draw first from 0 to 6 for a time period. What will be the load capacity? It will be 30 megawatt. We have to draw just like an graph. Next one is to calculate the load factor. Load factor is equal to average load to peak load. So how we can calculate the average load means, so here the average load will be 1560 divided by 24. So per day it will be 24 hours. So average load will be 65 megawatt. So maximum demand is 100 megawatt. So load factor will be 65 divided by 100. So load factor answer will be 0.65. Then load factor of a standby equipment. So here for a standby equipment supplies the power at 3 situation more than 70 megawatt. So for more than 70 megawatt, so 90 minus 70 we can get 20 megawatt for 2 hours. 100 minus 70 we can get 30 megawatt for 4 hours. 80 minus 70 10 megawatt for 2 hours. So energy generated is equal to area under the curve. So through this we can calculate the energy generated. So we can get 180 megawatt hour. Total operation hour for standby equipment is equal to 2 plus 4 plus 2. So totally 8 hours. So average load is equal to 180 divided by 8. So the answer will be 22.5 megawatt. So load factor will be 0.75. Finally the use factor. So use factor is nothing but ratio between energy produced in the given period to capacity of the plant into actual number of hours the plant in operation. So here the energy produced in a given period is 180 divided by capacity of the plant is 30 megawatt into actual number of hours the plant in operation will be 8 hours. So the use factor will be 0.75. In that same problem, so next one we have to determine the load factor for power station. What is the load factor for standby unit rated at 30 megawatt, then takes up all the load in excess of 72 megawatt. Also calculate its use factor. This problem is also what we have done before. In that same manner we have to do. Next problem. A peak load on the thermal power plant is 75 megawatt. The load having maximum demand of 35 megawatt, 20 megawatt, 15 megawatt and 18 megawatt are connected to the power plant. The capacity of the plant is 90 megawatt and the annual load factor is 0.53. Calculate the average load on power plant. Energy supplied per year, demand factor and diversity factor we have to calculate. First, what they have given, maximum demand or peak load is equal to 75 megawatt. Then capacity of the plant is 90 megawatt. Annual load factor is 0.53, which are all given in the given data. Then first of all we have to calculate load factor. Load factor is nothing but average load to peak load. So here they have given load factor and peak load. Through this we can able to calculate the average load. So average load is 39.75 megawatt. Energy supplied per year is equal to average load into number of hours in 1 year. So which is equal to 39.75 into per year 365 days for hours into 24. So per day it will be 24 hours. So finally energy supplied per year we can able to get 3,48,210 megawatt hour. Then demand factor. So demand factor is the ratio between maximum load to connected load. So here we can get the answer 0.85. Then diversity factor. So the ratio of sum of individual maximum demands to maximum demand of the whole. So through this formula we can get the answer as 1.17. Next topic is cost of electrical energy. So what are all the costs calculated for electrical energy? Here first one is fixed cost, next one is operating cost, third one is customer charges and fourth one is investor profit. So first in fixed cost there are three types of fixed cost. First one is capital cost of power plant, second one is capital cost of primary distribution and third one is other capital cost. Capital cost of power plant is nothing but cost of land, cost of building, cost of equipments, cost of installation, cost of designing and planning. So this cost used for this type of factors means these are all comes under capital cost of power plant. And next one is capital cost of primary distribution. Under this cost of substation, cost of transmission line. So cost money used for this type of work for fixing substation and transmission line, all these things are comes under capital cost of primary distribution. And last one is capital cost of others like insurance, tax, interest, general management cost and depreciation cost. And then for under operating cost, cost of fuel cost used for labor, salary for labors, then cost of material, consumable materials like oil, grease, chemicals, water. So all these things are comes under operating cost. Next one is customer charges. So under this capital cost of secondary distribution, cost of inspection and maintenance, cost of publicity, office staff for meter reading, all these costs are comes under customer charges. And then last one is investor profit.